Welcome to our YouTube channel Vidir Kalai WINMEEN JEE Main Exam 2022 Physics Memory Based Solved Question and Answers. Please subscribe, comment and share the video. Which logic gate is this? Options: NAND gate, OR gate, AND gate, XOR gate. Let's find the answer. When A is equal to 0, B is equal to 0 means both the diodes are in forward biased condition. So when the both diodes are conducting, we don't get the output, that is output is 0. A equal to 0, B equal to 0 means both diodes are conducting. As a result, the output is 0. When A equal to 0, B equal to 1. A is conducting, that is forward biased, B is reverse biased. Even in this case also the output is 0. If any one of the diode is forward biased, then output will be 0. Third condition, A equal to 1, B equal to 0. Now A is reverse biased, B is forward biased. In that condition also output is 0. Sorry. A equal to 1, B equal to 0, output is 0. Y is equal to 0 because B is conducting. B is forward biased. B is the input, but the diode corresponding to the input B is forward biased, so it is conducting. When any one of the diode is conducting, output becomes 0. Now the fourth condition, A equal to 1, B equal to 1. Both the diodes are reverse biased. As a result, we get the output 1. Now we can summarize the inputs and outputs. This is the truth table. A equal to A, B and Y. Only when the both inputs are high, the output is high. That means this is equal to, the truth table is for the AND gate. This is the AND gate, A and B. This is the output. When both inputs are 1, 1, we get the output equal to 1. For all other conditions, we get 0. For all the three conditions, we get output 0. Only for the last condition 1, 1, we get the output 1. Find the potential difference at AB. AB is the open terminal where 10 kilo ohm, 5 kilo ohm are in parallel. This 5 kilo ohm and this 10 kilo ohm are in series. The options are 475 volt, 385 volt, 275 volt, 365 volt. Let's solve this question. We need to find the equivalent resistance across the terminal AB. 10 kilo ohm resistor is in parallel with 5 kilo ohm parallel, and 5 kilo ohm another 10 kilo ohm are in series. As a result, we get 3.3 kilo ohm, 5 kilo ohm plus 5 kilo ohm plus 10 kilo ohm. So 18.3 kilo ohm is the equivalent resistance across the terminal AB. Voltage across the terminal AB is equal to current into current I is multiplied by RAB. RAB is the equivalent resistance across the terminal AB. I is given as 15 milliamps. RAB we found as 18.3 into 10 to the power 3 ohms. As a result, we get the voltage across the terminal AB 275 volt. Next question. In the shown circuit, for the value of find the value of V naught. In the shown circuit, find the value of V naught. Let's see the options: 4 volt, 2 volt, 6 volt, 12 volt. To find the output V naught, we need to find the current I1, I2 and I3. We need to find out I1, I2, I3. How to find out I1? I1 equal to 2 by 10 power 3. I2 equal to 4 by 10 power 3. I3 is equal to 6 by 10 power 3. Let's solve 1 by R equivalent. That is finding the equivalent resistance. All the three resistors are connected parallel. As a result, we get the equivalent resistance 1000 divided by 3. Total current I is equal to I1 plus I2 plus I3, where I1 is found as V1 by R1, I2 is equal to V2 by R2, I3 equal to V3 by R3. We know V1 as 2 volt, R1 is 10 power 3, V2 is 4 volt, R2 is 10 power 3, V3 is 6 volt, R3 is 10 power 3. As a result, the total current we found as 12 divided by 10 power 3. Now V naught is equal to I times R equivalent, where I is 12 by 10 power 3 times 10 power 3 by 3. We cancel the common terms in the numerator as well as in the denominator. We get V naught, that is the output voltage, as 4 volt. Here is the answer. Find I for the given circuit. Options: 0.723 amps, 0.523 amps, 0.923 amps, 0.623 amps. Let's find the answer. Before finding the answer, in this circuit, under the balanced condition, this is a bridge circuit. Here is the bridge circuit. Under the balanced condition, there is no current is flowing through the 5 ohm resistor, no current. So in such a condition, 3 ohm and 6 ohm are in series. Similarly, this 3 ohm resistor and 6 ohm resistor are connected in series. Now let's go for the solution. Under the balanced condition, no current will flow through the 5 ohm resistor. So 3 ohm resistor is in series with 6 ohm. Similarly, another 3 ohm resistor is in series with 6 ohm resistor. Now, finding out the equivalent resistance, 3 plus 6 in parallel with another 3 plus 6, and that is in series with 2 ohm. Now, calculating the equivalent resistance, we get 6.5 ohms. If you need more time, please pause the video and solve for equivalent resistance. And you can verify that R equivalent will be 6.5 ohms. And after finding the R equivalent, we can substitute in the Ohm's law I equal to V by R, where V is 6 volt, R is the equivalent resistance 6.5 ohms. As a result, the current is found as 0.923 amps. So our answer is option option C, 0.923. If electric field of EM wave is 540 sin pi 10 to the power 3 of x minus ct, and speed of light is 3 into 10 to the power 8 meter per second, then find the amplitude of magnetic field. Four options are given. Let's go for the answer. There is a formula E max divided by B max, where E is the electrical field, B is the magnetic field, which is equal to C, where C is the light of the speed, which is found as 3 into 10 to the power 8 meter per second. Using this formula, we are going to find out the B max, where E max is given as from the formula 540 volt. Substitute the value of E max and C in this formula. We get 540 divided by 3 times 10 to the power 8. As a result, we get 18 into 10 to the power minus 7 T. A potentiometer shows reading of 36 centimeter when connected with 1.2 volt battery. Then the same potentiometer is connected to a 1.8 volt battery. Find the difference in lengths. A 10 centimeter, B 18 centimeter, C 20 centimeter, D 54 centimeter. 36 centimeter is the reading for 1.2 volt. What is the reading for 1.8 volt? So we can calculate the reading for 1.8 volt as 1.8 divided by 1.2 times 36, which gives 54 centimeter. Now Finding the difference between 54 centimeter and 36 centimeter, we get 18 centimeter, which is the right answer. So option B is the answer. Magnetic flux as a function of time is given as 8t square minus 9t plus 5, and a resistor of 20 ohm is connected with T. Find the value of induced current at t equal to 0.25 seconds. The options are 0.35 milliamps, 0.15 milliamps, 0.45 milliamps, D 0.25 milliamps. Let's see the answer. According to the electromagnetic Faraday's law of electromagnetic induction, induced EMF is equal to minus d phi by dt. EMF is opposing the rate of change of flux. That is the main physical meaning of this equation. So the physical meaning you know. And substituting the value of pi, we get minus d phi by dt, we get minus d by dt of 8t square minus 9t plus 5. Differentiating pi with respect to the time, we get induced EMF, which is equal to minus of 16t minus 9. When t equal to 0.25 seconds, E becomes 5 volt. Please pause the video and solve for the induced EMF. We get 5 volt. And substituting the in the Ohm's law, I equal to V by R or E by R, we get E as 5 volt, R as 20 ohm, which gives 0.25 amps, or we can write as 250 milliamps. But if you go for the options, all the options are in different answers. We don't get 0.25 amps or 250 milliamps. It's all different. So 0.35 milliamps. I think here the typographical mistake. The answer is D, 0.25 amps. That is the right answer, or 250 milliamps. That will be the right answer. So option D will be the right answer. Breaking stress of a wire is increased by 2.5 times, and tensile force is increased from 10 to 25 metric tons. If initial minimum cross section is 2.5 into 10 to the power minus 4 meter square, the minimum area to sustain the load is, there are four options. Let's see the answer. Let's see the answer for this question. Give me a second, I will come back to this. Yes, there is a formula. I will solve here. There is a formula for A1, that is area, which is equal to F by sigma. Similarly A2. So we find the ratio between A1 by A2. We get A1 by A2, we get 2.5 into 10 to the power minus 4 divided by A2. A1 is given and we are simply substituting. A1 is F by sigma. F is given as 10 into 10 to the power 3 divided by sigma, that is A1. Similarly, A2, 25 into 10 to the power 3 sigma, sorry, it is 2.5, it's not sigma, 2.5. As a result, sorry, I will solve it once again. A1 by A2, which is equal to 2.5 into 10 to the power 4 minus 4 divided by A2, where A is found as F by sigma. So F is given as 10 into 10 to the power 3 divided by sigma divided by 25 into 10 to the power 3 divided by sigma. Sigma and sigma is get cancelled. As a result, we get 10 by 25 into 2.5, which gives 1. So A1 is equal to A2. Our answer is, if A1 is 2.5 into 10 to the power minus 4 meter square, A2 will also be 2.5 into 10 to the power minus 4. So our answer is 2.5 into 10 to the power minus 4. That is the answer. I hope this problem is clear to you. Let's move on to the next problem. A capacitor having capacity 2 microfarad is charged steadily and charge of 5 microcoulomb is given to it. Then the graph of potential with charge is given. Then the graph of potential with charge given is, 4 options are given in the picture. What is the correct answer? Let's find. There is a formula, we know charge Q equal to CV. From this formula, we can write V equal to Q by C. Q is given us, that is charge is given us 5 microcoulomb, that is 5 into 10 to the power minus 6 divided by capacitance value 2 into 10 to the power minus 6. So we can cancel out 10 to the power minus 6 both in the numerator and denominator. As a result, we get 2.5 volt per 5 microcoulomb, that is the charge. So when the charge is 5 microcoulomb, voltage we get 2.5 volt. So the flat is linear, the curve is linear. When from 0 to 5 microcoulomb, the voltage is rising linearly. So our option is A. Yes. Here is the right answer. 2.5 volt for 5 microcoulomb. Option A is the right answer. Conduction current, that is RMS, 6.6 microamps in a circuit with capacitor connected across 220 volt source. Angular frequency is 600 radian per second. Value of capacitance is 50 picofarad, 20 picofarad, 40 picofarad and 10 picofarad. Let's find the answer. I equal to V by Xc, where Xc is the capacitive reactance. Xc is the capacitive reactance. It is given in the formula Xc equal to 1 by omega c, where omega is the angular frequency in radian. I is given as 6.6 into 10 to the power minus 6. V is given as 220 volt. Substituting in this formula, we get C as 0.05 into 10 to the power minus 9. This can be simplified as C equal to 50 picofarad. That means 50 into 10 to the power minus 12 farad. So this 10 to the power minus 12 we can write as a picofarad. So our answer is A, 50 picofarad. A ray is incident inside glass prism, grazes after refraction as shown. Find refractive index of liquid. Here is the picture and the four options are given. Let's move on to the answer. According to the Snell's law, n1 sine theta 1, n1 sine theta 1 is equal to n2 sine theta 2, where n1 and n2 are the indexes for the two different medium. n1 is given as 1.5 and theta is the angle which is 60 degree. n2, what is the index n2 for another medium? Theta 2, from the picture we can calculate theta 2 as 90 degree. From this formula, n2 is equal to n1 sine theta 1 divided by sine theta 2, which gives 1.5 times root 3 by 2 divided by 1, where sine 90 is equal to 1, sine 60, which the value is square root of 3 by 2, and as a result we get 1.5 times root 3 divided by 2. Multiplying by 2 both in the numerator and the denominator, we get n2, that is the index 3 root 3 by 4, which is the answer. Two bodies with mass m and 8m have same kinetic energy. The ratio of their momentum is, four options are given: 0.5, 0.8, 0.25, 0.35. Let's see the answer. Momentum formula is square root of 2m1 kinetic energy times kinetic energy. Similarly, momentum 2, which is equal to square root of 2m2 into kinetic energy. Here the kinetic energy for the two momentum will be the same. So finding the ratio P1 to the P2, P1 divided by P2, which we get square root of m1 by m2, where we can cancel out the common terms in the numerator as well as in the denominator. Here the kinetic energy remains the same, and which gives m1 by m2. Substituting the value, m1 is 1, m2 is 8. As a result, we get 1 by 2 root 2, which is 0.35 is the ratio between the two momentum. So our answer is 0.35, that is option D. The the magnitude of magnetic field associated with an EM wave is 5 into 10 to the power minus 6. The electric field magnitude is going to be, the four options are given. Let's find the answer. Again, there's another formula. We are familiar with the previous problem. E max divided by B max, which is equal to E by B, which is equal to C. C is the speed of the light, which is 3 into 10 to the power 8 meter per second. From this equation, we can able to find E equal to B times C, where B is the magnetic field, which is given by 5 into 10 to the power minus 6, and C is considered as 3 into 10 to the power 8. As a result, we get 1500, which can be written as 1.5 into 10 to the power 3 kn by C. So our answer is 1.5 into 10 to the power 3 kn by C. So option B is the right answer. Find work done in moving a particle of mass 0.5 kg from x equal to 0 to x equal to 2. V is equal to 3x square plus 4 meter per second. Four options are 20 joules, 80 joules, 100 joules and 60 joules. Here there is a hint. Change of kinetic energy of a body is equal to amount of work done on that body. So using this statement, using the clue or using the hint, we are going to solve the problem. Work done, which is equal to final kinetic energy minus initial kinetic energy, that is difference in the kinetic energy. Kinetic energy for the x value of 2 minus kinetic energy for the value of x equal to 0. Substituting the formula for kinetic energy, half mv square. So half m of v of 2 the whole square minus v of 0 the whole square. Substituting the value of m and v, we get half times 0.5 of 3 into 2 square plus 4 the whole square. Here is the V formula. In this V formula, we can substitute x equal to 2 and x equal to 0 here. We get half times 0.5 of 256 minus 16. As a result, we get 60 joules. That is the work done. You can see W is the work done, which is equal to 60 joules. Dimensions of coefficient of viscosity with respect to momentum area or time is. Four options are given. This problem will be little bit confusing if you are not sure. It will be definitely a confusing one. Which one you will choose? Because you can see here two options are here which are similar. Here with the bracket, square bracket, and here without bracket. All the other option you can see it's different. Now how to find the answer for this problem? Dimension of momentum P equal to ml t power minus 1. Dimension of area A equal to L square. Dimension of viscosity which is equal to P by A. So substituting the dimensions for momentum as well as the area, we get this formula which is equal to P by A. This can be written as P A to the power minus 1. Here there is no time, so time is 0. So our correct answer is P A to the power minus 1 T to the power 0. That is the right answer. When a particle moves on a circular track from point A to B as shown, it covers a distance of 80 meter. Find the displacement of the particle. Cos 135 degree which is equal to minus 0.5. It's given. Here is the picture and the particle is moving from A to B on the circular motion. The four options are given: 46.2 meter, 62.6 meter, 45.2 meter and 58.1 meter. How to solve this problem? Angle formula is equal to arc by radian. In this picture you can see, so from this formula we can calculate radian is equal to arc by angle. What is the arc? Arc is given as 80 meter. 80 meter is given. What is the angle? 135 degree. Now converting this degree into radian. So 135 into pi by 180. We get 3 pi by 4. So the value is given. From this we can able to find out 320 divided by 3 pi, where AB is the chord. AB is the chord which can be written as 2 times AC. AC between from here to the middle, that is AC, where AC is written as R times sine theta by 2. I will explain this one. AC is R times sine theta by 2. Substituting the values, 2 times 320 by 3 pi, that is the value of R, and sine theta by 2. Now consider the triangle ACO. AO is the radius. Okay. Now finding out AC from this formula, sine theta by R times sine theta by 2, that is the value of AC. Substituting the AC value in AB, we get 2 times 320 divided by 3 pi times sine theta by 2, where sine theta by 2, which is equal to square root of 1 minus cos theta the whole divided by 2. Square root of 1 minus cos 135, where theta is equal to 135 degree. Now the value of cos 135 is given as minus 0.7. Square root of 1 minus 0.7 divided by 2, which gives square root of 1.7 divided by 2. Now AC is found as 62.6. Please pause the video if you need more time and verify that whether you are getting the answer 62.6 meter or not. So AC is the, here is the answer for AC, 62.6 meter. Now moving back to the question, the answer is 62.6. That is the answer. Y equal to 2 sine omega t minus kx. Find the wavelength lambda such that wave velocity is equal to maximum velocity of particle. Four options: 2 pi, 4 pi, 7 pi and 10 pi. Wave velocity is equal to omega by k. Particle velocity, which is equal to omega a. From the problem, we know that wave velocity is equal to particle velocity. Equating these two, we get omega by k, which is equal to omega a. Cancel out the omega in the left LHS as well as the right hand RHS. We get 1 by k is equal to a. Now another formula, 2 pi by lambda, which is equal to 1 by k. So substituting the value of k in this formula, we get lambda is equal to 4 pi. That is the answer for wavelength. Wavelength is 4 pi. Find the lambda. So we found as 4 pi. Answer is B, is the 4 pi. Find the ratio of time period of oscillations in two cases as shown. Assume that there is no slipping between M and 2M blocks in case 1 and case 2. Four options are given. Let's find the answer. There is a formula, time period of oscillation T equal to 2 pi square root of M by K. Case 1, T1 equal to 2 pi square root of 3M by 2K. Case 2, T2 is equal to 2 pi square root of M by 3K. Finding now the ratio T1 by T2, we get 3 divided by square root. So this is the answer. The ratio between T1 and T2, which gives 3 by square root of 2. Debye wavelength of proton and neutron have ratio 1 is to square root of 2. Find the ratio of their potential difference through which they were accelerated. Options: 6 is to 1, 3 is to 1, 1 is to 1, 4 is to 1. Four options. Lambda p, that is wavelength of proton to the neutron, which is given as 1 by square root of 2, which is given in the problem. Now writing out the equation for wavelength of proton as well as wavelength for the neutron, we get, and taking the ratio between lambda p to the lambda n, we get this equation. After cancelling out the common terms, from this equation we can square both sides. We get 1 by 2 in the left hand side, m by n, that is the neutron, the weight of the neutron, mass of the neutron to the proton is 2 by 1. This is the property. Charge ratio neutron to proton is 1 by 1. Substituting the values in this equation, we get half, which is equal to 2 by 1 into 1 by 1 into Vn by Vp. Vn by Vp, which is equal to 1 by 4. Vp by Vn equal to 4 by 1, which is 4 is to 1. That is the answer. Our answer is 4 is to 1. That is option D. Thanks for watching the video. Please subscribe our channel for more videos. 13 videos on various topics released so far. Please watch other videos too and share it with your friends. See you in the next video. Until then, it's goodbye from Vidyarkalai WINMEEN. Thank you one and all for watching this video.